Hey guys, what's up? This is the third tutorial in our series of C programming tutorials, and we're going to start off from the basics of inputting a character. Actually inputting a user input, that is. And these are the basics of programming. Every program starts with this standard library functions. There are a couple of videos before this, so if you haven't checked it out yet, you can always check it out at my channel. Lots of other cool things are also there in my channel, lots of other cool videos, you can also check them out. But getting back to basics of C, this is last time we learned how to input how to actually scan a user input. It can be a integer input, which is from 1 to, as far as you can think of, say 1 million, and also a decimal number, how to input a decimal number from the user, which is basically 5.9 or 7.8. And we also learned how to have the desired number of digits after the decimal. Well, by the usual the universal tradition of C, it uses 6 decimal places after the decimal point, but we can reduce that as to our preferences, like we can put 2 decimal places after the decimal, or 3 or 4 or 5, or we can keep the usual 6 as it is declared by C. Now we're going to learn how to input a character now. Okay, now remember, a character is anything from A to Z in both uppercase and lowercase. Okay, for example, suppose your name is John. Now it's John. Okay, suppose John, John is your name. Now John is not a character. Okay, a character has to be J or O or H or N. What we call John, the entire character, is a string. Now we need to open up Paint again, because that's where I can show you a little bit more detail about what I'm talking about here. Say I write, let's increase that font size to 20 or maybe 36. Okay, say my name, say name. Okay, this N is a character, A is another character, M is another one, and E is another character. Okay, so when we're talking about characters, we're talking about single alphabets, N, A, M, E, and all these characters together make up a string of characters, and that string of characters is declared in C by string. We're gonna get to string a lot later in this series, because strings are it is something which you really don't need to know right now. What you need to know right now is what a character is. Character, it can be from uppercase A to Z or lowercase a to Z. Some special characters like from 1 to 9, 0 to 9 actually, and some special symbols like say this is a special symbol, sorry, not that one. Special symbol 1, special symbol 2, special symbol this, all these are special symbols, okay, which we can also add as a character. Now back to C. Now we need to input a character. Okay, so first we need to declare as for integer, we declared an integer type variable. Now we're gonna insert a character type variable. So for integer we wrote int for integer. For float, which is a decimal point number, we write float float, and for character we write char. It's pronounced in different ways. It can be car or car or chair or whatever. Some people call it even char, which I don't like to call, because this is actually char from character. So you can call it car at the most, but not char. Alright, now car or char or whatever, that is the way you declare. And now you need to enter a variable where the editor is going to store the user input, say A. So char A is our variable where the user is gonna give a character, and we're gonna show that character to the user. That's what he entered. Okay, alright, now char A, that is our variable, just like in the integer one. The editor has defined a location in the memory, has defined a place rather in the memory. So this is your memory. It can be lots if you have, say, 1 TB, 1 terabyte of space. Now A, that is the space. Writing with pencils is too difficult, but you know, there we go. That's what kind of A, I don't know, but it's an A because we have declared an A as a variable, a char variable rather, and now we need to give the names of the places in the memory, the addresses rather. We'll go back to our size 12. Say this is 40421 4021. This is of course 4022. This is 4023, 4024, 4025, and 4026. Alright, so this is our memory location starting from 4.4021 to 4026. We have declared a char variable A, and this is the place which the memory has assigned to variable A. Now whatever the user is going to input, say it's going to input a capital A, so whenever the user inputs a capital A, it will be stored over here, and when we tell the editor to show us what the user has entered, it will actually show this A. Okay, now let's see how we do that. So we need to write printf to actually tell the user what to do. Printf enter a character. Right, enter a character, double inverted comma to say that this is the thing which is going to be printed on the console screen. We end the sentence with a semicolon, and then we need to scan that, scanf, what the user has entered. Now for integer we use %d, for float we use %f, and for char we use %c, small c, all these are small letters. Okay, double inverted comma, close, and then give a comma. Now all these are syntax. Okay, now whenever I'm writing a program, you need to pay close attention to what the syntaxes are, because if you omit this comma, it will give an error, and you're going to search the entire program for the logic, for the semicolons, or for the any kind of stuff. But if you don't get the syntaxes right, it's going to give up errors after errors. Okay, so a comma over there, and now we need to place an ampersand. Okay, and then A, because that's where we need to store it. Ampersand A means that user entered character will go to the address of A, that's 4021 or whatever the address is in your computer, in your memory, and then we need to print out what the user has stored, what the user has entered rather. You entered, and would like that in a new line. You entered %c, because we need to show the character which the user has entered, not an integer number or a floating point number. You entered a character, so character, then we close the double inverted comma because that's what's going to be shown on the console screen. We give another comma to specify that what is to be written in that character C, and sorry, the %c. Here we're going to write A because we don't need to print the address of A, we need to print only the value of A. Okay, close the first bracket, give the semicolon, and there you have it. We write get ch to hold the control screen until we enter a character, the curly braces, and there you have it. We enter a character, the user inputs a character, it's stored in a variable A, and then it's printed out as it is, as what the user has entered. We see for any errors, it's a success. Now we go to our control F9 and we see the program. Let's see, enter a character. Suppose I write caps lock on A, so uppercase A, you entered A, which is pretty cool. Now there are lots of different uses of this. When we get to string, which is a little bit later in the series, you can say, suppose what's your name, and the user enters his name, say Mike, and then you go on saying hello Mike. So what you basically do is you place that Mike in a string variable, which is an array of characters. We'll get back to arrays, and I keep on telling about things which you're going to see in the series, but those things you need not put it in your mind right now. Just understand this. We write the library functions char A because this is a character variable. We need to enter a character. We need to see what the user has entered as a character. So enter a character, scanf %A, ampersand a percentage c because we are using a character variable over here, ampersand a because we need to store that a in the memory location of that that assigned variable a. Okay, so now you entered percentage c because once again we're going to display a character, so percentage c and then a, not ampersand a because we don't need to print out the address, we need to print out only the value of a. When we need to store, we need to store it in the address. When we need to print out, we need to print out only the value of a, not the address. Get ch just to hold the control screen until we press enter or any other character from the keyboard, and then the end of the program by a curly bracket. Okay, now those are the most common three types of variables: integer, floats, and characters. There are lots of different types of other variables, lots of different modifications of these three more major variables, major types rather, like integer, float. There's long float and double, and all these are just modifications of the float, you know, and long integer, you know, and so all these are just modifications of these three major types, which I don't think you're gonna much need in your programming career. So but those three types, the integer, the float, and the character, are the most needed, and you need to keep a nice and very healthy grasp of that in order to program in C. Now in this tutorial we're also going to see some basic mathematical functions, you know, basic mathematical functions. So for example, the first thing I'm going to show you is how to do a basic addition in C. So int, we need two variables over here. Okay, we need two variables over here and a third one to store the result of that addition, because we need two first of all, when you're actually writing a program, you need to keep a clear idea of the logic. You need to think it in your brain about what the editor is actually need to do, what you would have done if you have added. First you need to see the two numbers. Those two numbers will be stored in a location of your memory. So I need two variables for that, a and b, and a third variable which we call sum is actually going to store the summation or the addition of a and b. Now we need to assign a value sum equal to 0 at the beginning, because if it is sum not equal to 0 at the beginning, what the editor does, it puts a garbage value into sum. So suppose a is 5, b is 5, the answer should have been 10, but since there is some pre-installed garbage value into sum, we do not actually we do not actually get to see the real answer since there is some garbage value. So we need to assign sum equal to 0 at the beginning, just to make sure that the sum is free from any garbage value. And when you're doing any multiplication, we need to assign that variable which is going to store the multiplied value as 1. So suppose if we have done a multiplication of a and b, we would have write, say, mult would be the variable which is going to store the multiplication of a and b, and that would have been basically not 0 but 1, since multiplication of anything into 1 would give us the actual result. So but for sum, we're going to write sum equal to 0. Alright, now the user needs to enter two digits. Okay, it can be any two numbers, rather it can be 1 to 1 million. Okay, so we need to write printf enter two numbers. Okay, now we need to scanf that. We need to scan two numbers. Now scanning two numbers, we can do it in two different ways. The first one, which I'm going to show right now, is obviously the more tedious one, which I won't recommend anyone to do. In fact, you're going to figure it out pretty soon that this is way too tedious and hard work to do than the second one, which I'm going to show in a little while. So for the first number, we write percentage d ampersand a. So that's the first number stored. For the second number, we once again write scanf percentage d, because these are all integers, ampersand b. We need to store that in the address of b, and then so that is how we store two different numbers by writing two scanfs. Okay, now suppose there are four numbers, or 5 or 10 or 12 or 20, so we can't go on writing scanf after scanf after scanf. So C has a greater way of doing that. What we do is we write percentage d, and we need to scan two numbers, so we write two percentage d's, give a comma, ampersand a, another comma, another ampersand, and B. So what this does is this first ampersand would be for ampersand A, this first percentage D would be for ampersand A for storing the number in variable A, the second percentage D would be for storing the number in ampersand B. Okay, so but remember, this only goes with same variable types. Since both A and B are integer types, we can do it this way. But if B would have been a floating point number, we would have had to write another scanf and then percentage F. Percentage D, percentage F doesn't go together. Okay, so that's how you write scanf, one scanf, two percentage D's, two ampersand. Now in C, everything is done in in a respective manner. Like this first percentage D would be for the first ampersand. Okay, it doesn't really matter, because if this would have been for the second one also, these are all integer types, these are all just the same variable type, so this wouldn't have mattered. But I'm just telling you because we're gonna see it in the next while that everything goes very chronologically, that number 1 would be going with A, 2 would be going with B, 3 would be going with C, just like that. Okay, so that's how you enter two numbers, percentage D, no comma or space in between. After the double inverted comma, we give a comma. For the first percentage D, we write the first variable we need to put the first number, then another comma. For the second percentage D, we give the second variable name ampersand B for storing the second number. Now we go to sum. Now remember, we have assigned sum is equal to 0. Now we're going to assign what sum would actually store. Sum would actually store the value of A, not the address of A. I'm not going to write over here ampersand A, because we need to add the value of A, not the address. Okay, sum is equal to A plus B. Then we give the semicolon to declare the end of the sentence, and then we just going to print out the sum. So printf, I would like that in a new line, the sum is, and here it would be another percentage D, because sum would actually store an integer value. Even if it is 1 million plus 1 million, that would give 2 million, that would give an integer value, not a floating point number or a character. So percentage D, we end that with the inverted comma, double inverted comma, give the comma, and then we write sum, not the address of sum but the value of sum. Okay, give the semicolon, and then we write get ch just to hold the console screen rather, and the curly braces are already there from the last program. Okay, so once again, just to go through this simple summation program, stdioh for the standard input output library function, the conio.h for the get ch, void main, because once again this doesn't return any value. Now by returning any value, you got to be thinking that, come on, it returns the value of sum, it returns the value of the character, but that's not a returning of value. I'm going to get back, these are pretty like complicated stuff, you know. Returning a value is from a function, from one function to another. We'll get back to these a lot later in the series, perhaps around the 14th or the 15th tutorial. I don't know even I'm gonna get to those in this part of the tutorial, in this basic C tutorial, or I don't know that. But these doesn't return a value as for now. Just remember this, these programs doesn't return any value, so we are writing void over here, which is empty. The curly bracket to start the program initializes the program integer, because we are actually going to take up integers. A and B for storing the two numbers which the user inputs. Sum is equal to 0. We need to assign sum is equal to 0, because if we don't do that, the editor is going to put any kind of garbage value into sum, and we don't want that, because that is not going to give us the direct result of the addition. Okay, so sum is equal to 0. Then printf enter two numbers. We now need to enter two numbers which the user is going to actually input. Now scanf percentage D, no spaces or commas in between, within two double inverted commas, just to initialize that these are all integer type numbers. And then ampersand A, ampersand B for storing the first number and the second number. And then we correctly give what sum would hold actually, not 0. That would be A plus B, the value of A and B. And then printf in a new line, the sum is percentage D, because sum is basically an integer type number, and comma, then sum for printing the sum. Alright, we alt F9 that, it's a success. Sum is assigned a value, but that is actually a warning. Okay, sum is assigned a value, but what it is telling us that if we don't even assign sum as 0 here, it's a success over here, because let me tell you something, this Borland C++, it's a much more modified and technologically advanced C++ editing program than Turbo C or the other that you have, so I believe it doesn't store any garbage value, but just for instance I would prefer to write a sum is equal to 0 over here. It doesn't do any changes to the program, it's just in warning. Okay, ctrl F9 to start the program, enter two numbers, say I7, and when you're entering two numbers, if you write 7 and then 9, that would, the editor would take it as 79. You need to press a space or an enter to give the second number. Okay, 79 and say 21, that would give us a sum of 100. The sum is 100. Okay, now even if you don't give sum is equal to 0 over here, it would come as 100, which is pretty sure, because this is a much more modified and technologically advanced programming editor. So sum is equal to 100. Doesn't matter which way you put it, but it's still like a sum is equal to 0 over here. So that's it. So now you learned how to input a user, how to scan a user character, user given character, and you also learned how to perform the summation, the simple summation on a C editor. Okay, in the next program we'll look at subtraction, division and multiplication, which is just basic types of programs, just like summation. You just put a multiplication, and instead of plus we just give a multiplication sign or a minus for a subtraction sign. Okay, that's pretty simple as that. Alright, we'll get back to you in this the fourth program in this series of basic C programming. Thank you for watching. Subscribe and like the video. Post your comments. If you don't get anything, just post a comment and I'll get back to you as soon as possible. Thank you for watching. Bye bye.